What is the stack? Stack is actually the same as queue, just we follow a different approach. In the queue, what we do, we follow first in, first out. So if a person comes first, he actually gets service first. And in the stack, what happens, the last in, first out. So whoever comes last actually gets the service first. To understand stack, there are some very basic examples. Let's assume that you are actually keeping plates. Okay, so you have a, let's assume you have a box like this, and in this box you are actually keeping your dresses. Okay, so that this is actually, let's assume this is your first dress, then you have on top of it you have kept another dress, and top of it you have kept another dress, and in top of it you have kept another dress. So in this, whenever you open this, okay, whenever you open this, the dress 4 that you kept at last will be at the top of the box. Same can be said in terms of plate. Let's assume you have kept some, you have washed the dishes and you have kept the dishes in a box. Okay, now what will happen, or in a basket? The first dish that you kept will be in the bottom of the box, then the second dish, then the third and the fourth. So whenever you are actually taking the dishes for using, you will always take the fourth dish first. So this is the basic idea, that whenever we are using a stack, okay, items are actually kept one after another, okay, in a way that the first item that you keep goes into the last. Now, is this the only representation of stack? Obviously no. There are many other ways we can represent stack, but this is the simplest of all to understand. So let's assume these are the plates. So whenever you actually were filling up this, the first plate or the first dress that you kept in the bag will be in the bottom of the basket, then the second plate, then the third and the fourth. And whenever you actually open to take a dress or take a plate from this box, okay, the plate that, or the dress that you kept at the last will be at the top of it. So here, as you can see, that this is called a stack. Whenever we actually insert an element, okay, it actually stays onto the top. Now, what happens, the top of the stack is the most recently object pushed onto the stack. That means whenever we are using stack, the most recent object that you actually keep will be in the stack. So let's assume instead of using 4, what if I actually keep only one plate? So if I keep only one plate, the plate will be here, and whenever you open the box, okay, whenever you open this box, the first plate that you will get is the plate number 1. Okay, so the last object that you keep will be the first one that you have, that you'll have. Okay, now there is another problem here, is that, okay, just give me 1 second. So there is another problem here, is that we know that how stack work, the elements are actually get pushed onto the last, but what if let me just pause one. Now, what if, you know, that instead of using one item, if I push 2 items, what will happen? So again, if you keep 1 plate, this will be here. If you keep 2 plate, the second one will be at the top. If you keep 3 plate, the third one will be at the top. The main thing is, whenever we are adding items into the stack, the last item added will be at the top of the basket or top of the list. That is what you have to remember. Okay, now let's go to the next one. What are the applications? Okay, we know that what is a stack. We use stack into various fields you just cannot imagine. It's basically everywhere. Okay, starting from parsing code, whenever you are actually writing a program, okay, whenever you call one function from another function, that is called tracking function calls. Okay, or whenever you're dealing with redo, undo operations. Okay, just think that if you're in a if you're doing some task, and sometimes you actually we can undo the task. Okay, so whenever we can undo the task, okay, what happens, the last task that you did actually gets reversed. So that's also where we use this stack. Reverse police calculators, assembly language. Now for our course, I will actually show you this application, how actually reverse Polish calculators work, and then this is actually our main topic of study. So first we will see the theoretical part, that given equation, okay, how can we, using stack, how we can actually calculate some equation, and then we'll see the code as well. So this is our topic of interest. Now, remember that stack, just like a queue, is a very simple data structure. Okay, so why we're calling it very simple? Because you don't have to worry about how everything is done behind the screen. You just have to worry about some basic functions: how to create a stack, how to push elements into the stack, how to insert, that means how to erase from the stack, and so on. So your task, just like the queue, is not to get in behind the idea of how stack work. Okay, you just have to know that how to use the stack. Now, though it's not the it's not important to actually understand how stack work, we will still see two operations for stack: one using single linked list, another is one-ended array. So let's go one by one. It will actually help us to understand stack a little bit better. So first of all, let's see how the basic program. So these are the functions that we use into the stack. So boolean isEmpty. This function returns true if empty. That means if your stack is empty, okay, you can, whether your stack is empty or not, you can check with this function. Then is full, you can check whether your stack is full or not. So let's assume we are using a stack having 10 items. So you can actually check whether it's full or not. Then void push, you can add items to the stack using name of the stack and the item that you want to push. It can be an integer, it can be a object, it can be a string. The item can be anything. Okay, you just have to write void push, you just have to write the name of the stack and then the item, and then you have to pop from the stack. You have to clear the stack. Oh, sorry. Pop function will actually remove the most recent item. Clear function will remove all items from the stack. Top item will retrieve the most recent. Now here, try to understand the difference between pop function and top function. Top function only retrieves the most written item. So if we are using a stack, and if 5 is the most recent item, or let's assume 2 is the most recent item, what the top function will do, it will return you 2, that it will say that this is the top recent item. What the pop function will do, it will remove this item. So that is the difference. It removes the most written items and it just tells you what is the most written items. So that is the difference between pop and top. And as you can see, the different return type is also different. In the pop function, the return type is only void. That means you are not returning anything to the user, but here you are returning the item. And finally, top and pop. What does this do? This actually combines the top function and pop function. It will tell you that what is the recent item in the list, in the stack, and then after telling you that 2 is the most recent, it will remove 2 from the stack. So this is basically the functions. We'll talk more details about them. Don't worry if you are not clear. Let's go to the next one. So here is some sample operation that we will see, that this is a basic program that we will see about stack. So what is the starting step? So first, as like all data structures that we have done in the linked list, the first step is to declare or allocate the memories. So first we will create a stack, that is, we'll name it S. So as you can see, there is actually a very common simplicity. Okay, so how is the simplicity? So for example, is stack, okay, is the type of data structure that we're using. Whenever we're creating queue, we use QA or QB, or you can name Q Sakib. Okay, you can name Q IOBT or stack IOBT. It's just a variable, just like integer X or array X. You can use any variable name you want, but the data type has to be stack. Then here you have to actually use the size of stack as well. Then we use push function. Okay, push A, push B, push C. What this will do, okay, let me just draw here. So let's assume this is the first an empty stack. Okay, I am actually drawing this line so that you can actually understand the difference between different items. So whenever I write this first instruction, push A, it will first send A, and A will go at the bottom of the stack. Then it will push B. So B will go here. It will push C. So C will go here. So this is the first 3 step done. This allocated memory, this pushed 3 items to the stack. Now D equals to top. As you have seen, what does top do? Top just shows you what is the recent element. So this line will return C, because C is the most last inserted element. Pop S, what this will do, this will actually remove C. So after using the pop, the stack will look like this. So C will be gone. Then again, we are using push E. So what will happen when I write push? Okay, wait. It will insert E. So it will be E will come here. And finally pop S, okay, what it will do, it will like remove E. So after all these operations are done, okay, my stack will look something like this. Let me, so B and A will be still here. So this is the basic steps of how stack work, the mathematical example of stack. Now, so far, what we have seen, okay, before going to the implementation, we have seen what is a stack, what are some applications of stack. We have seen some of the functions that we use stack, and using those functions, we have implemented a simple stack. Now, one question that should come to your mind, or if not, let me answer you, that here we are actually pushing characters. If we want to push string, what changes we need to make? If I want to push integer, what changes you need to make? The answer is, okay, there are sample codes for all of the types. If you want to push an object, you can push an array, you can push a whole function into the stack. You don't have to worry about the data type. You just have to mention at the start of the programming that which type of data you are dealing with. So if you are actually dealing with integer, you just have to mention stack will be integer. I will show you a code of how we declare, but basically stack S, and here it will be integer. Then if you are dealing with the array, you just have to mention this is an array. That's it. And then you can use a push, pop, and top, any other functions here you want. Now for the second part, we will see the linked list application. So how we can actually use stack using linked list. Now, ideal case is better to actually learn the code for this one, but now we don't have time. So let's just go to the theoretical idea of how it works. So basically we know that linked list, okay, is actually one node added after another node. And let's assume we are using a single linked list. Okay, so let's go from the last example. Okay, A, B, C. So here, if I'm using this example, pushing A, B, C, okay, what happened? Let's go for my linked list. So first it will push, let's assume A, then it will push B. Okay, my bad. Let me type in the text. So A, from A, we'll actually, let's assume we have a link that will push B. From B, we'll push C. So this is how it will be added, right? Now, as you can see, which one is the last added element to the stack? Oh, sorry, the linked list. Obviously C, right? We can all agree C is the last element. Now, if you want to find an element from the linked list, the find operation will take complexity of order of 1. Insert operation will also take order of 1, but erase operation will take from the front of it order of 1, from the end of it order of 1. Now this is, we have to understand that given I have this linked list A, B, C for the stack, why the find operation is only order of 1. So let's assume that we are using linked list with 2 pointers. One pointer is head, another pointer is tail. So if I want to see which element is the front of the linked list, okay, what complexity it should take, we just have to check the head. If I want to see what is the last element or the recent element that I have added, what I have to do, I just have to check the tail. So the head will point to the first item that we added, tail will point to the recent item that we have added. So to find the item from the first and from the last from the linked list or the stack, it should not be a trouble. So let's assume that this is the actual figure of the stack. So normally, as I have said, it will look something like this. So normally whenever we are using stack, whenever we write pop function, what the pop function does, it removes C. Okay, so here, okay, here if you actually want to remove C, what you have to do, you just have to remove that node that is pointed by tail, because tail is the last element. Again, normally if you have this stack and if you want to delete C, what you have to do, you just have to write a pop function. It automatically removes the most recently added element. Same way, if you use a linked list and if you want to remove the most recent element, you just have to go to the tail, and we have a pointer that stores the tail, so it's the order of 1. If you want to insert, okay, if you want to insert another element, let's assume you want to insert D. Okay, so what you have to do, you just have to go to the tail, the last element that is added, and then tail next will be D. Okay, if you're finding this confusing, I will suggest you go back to the linked list a little bit. Okay, we're just applying basic linked list here. Then if you are trying to apply erase, that if you want to erase from the last of it, you just have to remove tail and you have to update the tail to last one. So all this operation are basically very simple, but only this one is actually complicated. Now we have to understand why this one is complicated. Go to another topic, then we'll come back here. So let's assume that we now know how to use this 3 basic operation. That we want to insert at the end of a linked list, we can remove from that end of the linked list using a tail pointer, okay, and we can actually find from the end of the linked list. So we can actually apply push, we can apply pop, and we can also see top. So this is the linked list implementation. Now if I go to the next one, what is the, you see in the array implementation, it's actually more complicated. Why? So first of all, let's just imagine that in the array, you are trying to actually insert 3 elements. Again, we have A, we have B, we have C. The same problem that happened all the time will happen again. So this is your array. Normally, whenever we store items to the array, we first insert A, okay. Now, then we will insert B, then we will insert C. So far, no problem. The problem is that if this is a one-ended array, okay, and if you want to find something, you can go linearly. This is very simple. Okay, it doesn't matter whether the item is at the front or the back. You can just use a linear operation. The problem is if you want to insert, okay, and if you want to maintain the order, so you have to find which one was the last element that was added. So you have to insert here. Now, if you're using a loop to actually keep track how many, or a counter that how many elements you have added so far, this actually becomes very easy. So basically you will keep a counter that if 5 elements are added, next element will be added to array 5 plus 1. If 3 elements are added, next element will be added to array 3 plus 1. So these are actually very simple. But the problem occurs that if you want to actually remove the array elements. So let's assume someone give you an idea that, hey, instead of keep tracking all this, why not just, you know, first add A, then whenever there's a new item B, okay, so what you will do, instead of inserting B here, remove A to this location and insert B here. So this one actually becomes a little bit problematic. Okay, now the question might be asked that why we will do this, why we will go through all this trouble. Okay, so this actually requires a little bit detailed explanation that we don't have time for now. But for now, let's understand just the problems, okay, and how it works. And then, inshallah, if we have time, we'll come back to the details. So this is the function of how you can actually create or declare an stack. So this is called the top function. So what does the top function do? If you see, first you have the type. So what is the type of data that you are actually inserting into the stack? The type might be integer. So it will be integer, stack, integer, top, const, everything will be same. The changes that you need to make, here it will be the type, here it will be the type. Let's assume integer, integer, okay, and rest of it will stay same, no changes, okay. So what we are doing, we are implementing the top function using an array, okay, and we will decrease the size of the array by 1. Why did you decrease the size? Because we are actually removing an item. Now, there might be one question that not every time whenever we have the top function, we actually don't remove the item, right? Whenever we are using the pop function, we remove the item. Then why should we actually do this one? This is actually, if you look closely, we are not changing the size. We are just returning the array value of 5. This is one mistake that most people actually do. So let me again clarify. in this one, we are not changing the size of the array. Okay, we are not making stack size equals to stack size minus 1. What we are doing, we are just returning, if the array size is 5, we are returning the last 5 minus 1. Now you might ask, sir, why we are returning 5 minus 1? Okay, because if we start from 0, okay, what the last element that I added will be in the 4th location. So let me show you an example. So let's assume you are using array start from 0, and you have added how many items? You have added 5 items. Okay, so first item is this one, second item, third item, fourth item, fifth item. So you see the 5th item is in the array 5 minus 1. So if you have 5 items into the array, the last item will be in the 5 minus 1 in the 4th location. Then again, the pop function, you see here, the difference is everything is same, but here we are actually decreasing the size of the stack. And we are actually returning the stack last element. So this is another difference in the pop function. Now let me pause the meeting here.